So what we have here is the basic form of log right here. And sometimes you might see that written with not in function notation, but with a y instead, but that's no problem. So y equals log base b of x. And then these two special logarithmic functions that are down at the bottom are just two bases that are so popular when working with logs that they have their own way of being written that's different. So log base 10 is something we use so often that you can just drop the 10 and people will know what you're talking about, right? You can just write log x and the 10 as a base is implied, so you don't have to write it. Kind of like how we don't write 1 as an exponent. It's just implied. If there's no exponent, you just know it's 1. And then the second base that's very common when working with logs is base e. We talked about e last week. And we call this the natural log, and we can write it instead as just ln x. Anytime you see that, you understand that it's log base e. And we'll come back to this later in the lesson. We're going to start the lesson by evaluating logs. That means finding the value of them. So for example, the first one is asking us to determine the value of log base 6 of 216 without using a calculator, okay? And you probably don't know this off the top of your head. And what I'm going to do is give you some steps and a systematic way of approaching these problems to help you out and get started with that, okay? And the first step is going to be that I want you to set it equal to x. And that makes sense, right? So think about, we're asking ourselves, log 6 of 216 equals what? Well, I don't know what it equals, so I'm going to put a variable there as a placeholder. And now what happens is I have this equation, and I can use the lasso tool to rewrite this function. Right? So the rest of step 1 is this. So set equal to x and use the lasso to rewrite an exponential form. All right, so we're going to go ahead and do that now. When you're rewriting with the lasso, you start at the base, which is 6 here. You loop around and end where you started. So we rewrite it as 6 to the x equals 216. And this is something that we have worked with before, right? So the next step is going to be rewrite both sides to have the same base. Rewrite both sides to have the same base. So if you're trying to decide what base each side should have, a big clue here is that on the left-hand side, first of all, we already have a base. It's 6. It has a power of x. And 6 can't really be rewritten in terms of any other base. So chances are really good that's the base that we want on each side. So I'm going to start by keeping the left side 6 to the x and writing 6 as a base on the right until I can figure out what power I need, so that will equal 216. So then I just do some trial and error in my head. I'm going to change colors and do some math over here. I know that 6 to the 1 is 6. I know that 6 to the 2 is 36. And that's basically as much as I have memorized for 6's. So let me just by hand do 36 times 36 and see what that gives me. and that gives me 216. So 6 to the x equals 6 to the 3. And then the last step is set exponents equal and solve. So that means let x equal 3. And I don't have any more solving to do here, so I can just box it. For the next problem, I want you to just do step 1. Now, if you're feeling like a ninja, you can continue and do the other steps. If you're feeling less than a ninja, at least do step 1. All right, so hopefully you set it equal to x. Then you started at the base of 5 and did lasso to rewrite. So that gives you 5 to the x equals 1 over 25. And then here's the step where we need to rewrite both sides to have the same base. And this is a little bit tricky because there's a fraction on the right-hand side. So I'm going to keep the left 5 to the x because there's really nothing else I can do over there. I can't rewrite 5. It's just 5. But recognize that on the right-hand side, even though it's a fraction, I can sort of try this out. I can rewrite 25 as 5 squared, and at least I'm getting somewhere similar, like I'm making progress. Maybe I don't really know right now what to do next, but it does look like I'm getting closer to having a base of 5 on both sides. And then the step from here that I want you to remember is our negative exponent rule. That says you can flip the base, so 1 over 5 becomes 5, and then change the sign of the power. You take the opposite sign, so it becomes negative 2. And so now that we have the bases the same, we just set their exponents equal and solve, but we don't need to solve because it's already done. And some other scenarios like this, just for a little bit more practice about recognizing this negative exponent rule. If you had 1 over 36, you could rewrite it as 1 over 6 squared, which could then be rewritten as 6 to the negative 2. And it doesn't always have to be squared, so let's do something cubed. 8 is 2 cubed. And so if I had 1 over 2 cubed and I was trying to rewrite it, I could rewrite it as 2 to the negative 3. So just keep that in mind. We're going to do one more problem like that on the next screen. Does anybody need this screen up anymore? Okay. Try this problem on the bottom first. It works like what we just talked about. And then after that, we'll do the one on top. Okay, so step 1 was set it equal to x. Then do your lasso. Then rewrite the right side as e to the negative 5, and then x equals negative 5. Okay, and then I want you to try the top problem. At least get through step 1. There's some review that we need to do about that problem, but you might already remember what to do. I know Andrew already got this answer right, so I think he already remembered where I'm going with this. But let me slide up. Do the first one at least through step 1 where you rewrite it using lasso. Okay, so hopefully you set it equal to x. You did your lasso, which gives you e to the x equals the cube root of e. And then you're thinking to yourself, okay, I need to rewrite both sides with a base of e. But the right side has a radical, and I don't know what to do about that. Well, you just need a little bit of a baby review about how you can convert from radical form to exponential form, or with a power or exponent. Remember that things like square root of x, for example, you could rewrite as x to the 1/2. Remember, it's the root on bottom and the power on top. X cube rooted could be rewritten as x to the 1/3, so forth and so on. If you had a fourth root, you could rewrite it with a power of 1/4. So once you remember that, the rest of this problem's cake. Cube root of e can be rewritten as e to the 1/3, and now your bases are the same, so you just pop off the exponents and set them equal. Solve if you can, but we don't have to because it already is. There's no more steps.